I guess I'll go over some unit conversions. Use it a lot in physics and engineering, just basically science, chemistry, and stuff. So let's go over that, and it's very helpful to understand what's going on. You don't have to work a whole bunch of these problems. If you just sort of understand what it is that you're doing, then you should be okay. So let's get started with something simple. Let's try. Let's say you wanted to know how far 10 light years is in nanometers. Okay, so you get some part of a question that says part of a question is asking for the length, or a whole question, who knows, the length of 10 light years, but in nanometers. So let's start with what we have to begin with. First, we have 10 light years, right? So I'm going to write down what I know already. 10 light years. Okay? It's the first step. Write down what you already know. Right? Write it in parentheses. You don't have to. You don't have to write it like this. I've seen some people do conversions without parentheses. It just helps me. So start another parenthesis. Let's say I wanted to go from light years to miles. I can go straight to the metric system, but just so you know, and maybe you'll remember this, is so we have 10 light years and we have 1 light year, which is equal to 6.2 trillion miles. What is 6.2? What's 6.2 trillion in scientific notation? I think it's times 10 to the 12, right? Let's see. Let me think here. So 2. I'm just going to add a bunch of zeros blindly because I know it's a bunch of them. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know. Let's see. So here's 100,000. Here's 100 million. And here's 100 billion. So good. So here's 6 trillion. So 6.2 trillion. So if I was to write this in scientific notation, it would be a point right here, and then 1 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, so 6.2 times 10 to the 12. Okay. So this is in miles, right? Okay, so let's say I want to go from miles to kilometers. So 1 mile is equal to, let's see, how many kilometers is in a mile? Let's think here. It's about 1.6 kilometers. Now, let me make sure. I mean, I could figure it out. Every 5 kilometers is what, 3.2 miles or something like that. Well, who cares? Let's look it up real quick. There it is, right? So 1 mile is equal to 1.6. Good. 1.6. Let's just keep it at that. 1.6, right? Okay, so so now we're in the metric system, right? So we've gone from light years to miles, now to kilometers, and let's go. We're already in the metric system, so now things just got easier, right? So let's go to meters. So 1 kilometer is equal to 1,000 meters, right? And so now from meters, we can keep on going. We can go to millimeters, centimeters, or centimeters and millimeters, and then so on and so forth. But we're already in SI units here. So we went from kilometers to meters. So here it's a little more straightforward. I can go straight to picosecond, or I'm sorry, picometers or femtometers or whatever I want to do. But we're just going to nanometers, right? So let's say in 1 meter, or here, 1 nanometer, in 1 nanometer, there's 1.0 times 10 to the negative 9 meters. So good. So let's look at and see what I've done. So I started with light years, and the reason why I put these parentheses here and wrote this as a fraction like so is so that I could easily see this is in the numerator and this is in the denominator, and since I'm multiplying, I can just cancel these out. And so we've gone from light years to miles. Now we want to go from miles to kilometers. So notice in the numerator I have miles, and here in the denominator I have miles. I can cancel those out. And now we're in kilometers. So I do the same thing here. I want to go to meters. So cancel these out. And then from meters, I want to go to nanometers. Great. Cancel these out. And now I can do my calculation. And just grab my calculator to make it quick. So 10 times 6.2 E12 times 1.6 times 1,000. Everything is going to be divided by 1.0 e negative 9. So then 10 light years in nanometers is equal to 9.92 times 10 to the 25 nanometers. So if you understand this process, then it's the same thing with everything, right? I mean, we can start off with kilograms and then go to milligrams or whatever grams you want to do, right? And once you get to the one little trick that I use actually, and you don't have to do this, I do. I don't. It's kind of like a lazy shortcut sort of thing. But if somebody gives me, let's say, 15,000, let's say kilometers, right? So I know right away if I wanted to just do it however, all I have to do, if I want to get this to meters, for example, all I have to do is say, oh, okay, well, 15,000 kilometers is equal to 15,000 times 10 to the 3 meters. So I know that meters, there's going to be more meters than in kilometers, right? So then I tack on the times 10 to the 3. So, because remember, in every kilometer there's 1,000 meters. So that's all I did. So I took this and I multiplied it times 1,000. And so, you know, it's the same thing with, let's say you have 10 meters. 10 meters, right? And then you want to get to centimeters. Okay, I know for every meter there's 100 centimeters, right? So then I say, okay, I'm going to write this in centimeters. So that's 10 times 10 to the negative, or actually not to the negative, right? This is going to actually be to the positive. So meters is greater than centimeters, so this will be times 10 to the 2 centimeters. So it's just a quick conversion. Of course, here we couldn't just do it like that, right? Because we have light years to miles to kilometers to meters to nanometers and that sort of thing. So, or even if we were to go from kilometers to nanometers, you may not see it right off the bat, or you may. Who knows how good you are at this kind of thing. So this is saying 1,000 centimeters, right? So for 10 meters there's 1,000 centimeters, and that makes perfect sense. So I hope this video was helpful, and I'm also going to make a couple, let's see, on unit analysis and frame of reference, which are really basic for physics, and if you don't get them correct, you decide to go further into physics, or if you're taking a second physics course or something like that, then you'll be in trouble if you don't learn it well. So anyways, well, I'll catch you later.